So am I audible? Hello? Yes, am I audible?
Yes, sir.
Yes, request you to wait for I think 2 to 3 minutes and let the other participants also join. Then we'll start the session. Okay, so meanwhile others join, I request you to kindly update me if you have any doubts so that we can discuss. Meanwhile, so we are at the week 12 of the live session on the NPTEL course Electrical Measurement and Electronic Instruments, and there is a brief bio about me. I will be your TA for this session. And yes, so any doubts regarding the previous weeks or the current week lectures or the numericals that you are facing any difficulty, you may let me know. Yes, any doubts in the concepts or solving the problem? Am I audible? Yes, am I audible?
Yes, sir. It is audible, sir.
Yes, so kindly, if you have any doubts, you can let me know. Any doubts you are facing in solving the previous week's problem, because tomorrow we'll be having a overall discussion on the all the weeks, and we'll be covering some of the numericals. But if you have some doubts, you can let me know. We can discuss on those, and then or otherwise we can go ahead with this current week concepts and problem solving. So any doubt, you can just let me know. We can have a discussion on those concepts. No doubts? Or you haven't solved the problems yet?
Sir, I have a doubt on week 11 first question, sir.
Week 11. Okay.
Yeah. First question, I did not get the same answer what you posted over there.
So let me see what is week 11 first question. Okay. Yes, so we have a 555 timer based circuit. I think, yes. And we have a SR latch. Right? That problem?
Yeah, yes, sir. That same problem, yes, sir.
So see, they have asked you to calculate the peak to peak value of VC. So this same kind of problem, not the exact same problem, but more or less the same problem we have discussed already in the previous week. So what you need to do actually, so I'll just give you the brief over the problem, what you need to do. So maybe I can just share the screen, or maybe I can share the screen, or let me open here only. So it's a basic question. If you understand the circuit, then it will be very easy. And the working of the 555 timer. Basically, the question is simple because the actuation is done by the SR flip flop, nothing else. So I'll just show you by sharing the screen. So now I think you are able to see the problem on your screen. So this is week 11, problem 1, right? So the concept of this is that this particular switch is actuated based on the level of the voltage of the capacitor. This capacitor. So this is a Smith trigger arrangement. Okay. Smith trigger toggling arrangement. And how it toggles? Based on this voltage. See, this is going. to both comparator, you can say. So this stage is coming as a feedback from the SR latch, which is turning on and off this transistor. So once this transistor is on, it becomes a simple circuit. How simple? Because if transistor is not, say, on, if this switch is open, then you can see the voltages here. What will be the voltages? Can anyone tell? So what is this voltage? Can anyone tell?
So that is 12 volt, 12 volt, no?
Yes, 12 volt, this one. Then same 5, 5, 5. Three resistances are there, so equal voltage drops will be there. 1/3, 1/3, 1/3. So first this resistance will come. So you have 3 volts, sorry, 4 volts, because 1/3 of 12 volts. So 4 volts here, because this is grounded, right? Then you have 8 volts here. Then you have 12 volts here. So if this is VCC, you have this as 2 VCC by 3. And this as VCC by 3. Right? So once voltage goes above this 2 VCC by 3, then this is the upper threshold point. You can check, cross check. How? Because if voltage crosses 2 VCC by 3 point, this voltage I am talking, capacitor voltage. Okay, just see this red line. This red line is going on the top comparator at the plus, that is the non-inverting end, and in the minus in the lower one. So voltage is now how much? 2 VCC by 3. And let's suppose voltage is going, it is crossing the limits of 2 VCC by 3, right? Because you assume any state of the transistor. So if the 2 VCC by 3, it is going crossing 2 VCC by 3, then what is happening to this SR? Then this is what? This is a high signal, right? And this set is 1 in the form of that high signal. And what is this reset? Yes?
When it is 0, it will be reset. There is no voltage.
Yes, because the voltage is now VCC, 2 VCC by 3 and beyond.
Yeah.
So it is obviously the negative port voltage Vn, and if this is Vp, then you see what is the Vp. Vp is VCC by 3, but Vn is VCC by 2 VCC by 3. So obviously it will be a low command. So reset is R is 0. Logic. So if set is 1, then Q is 1. If Q is 1, then this transistor gets activated in the form of logic. I am telling at the voltage levels. Consider V out being VCC or more plus VCC or more as logic high, and V out being minus VCC or less, that means lower. But minus VCC is the lowest point that it can achieve. So, but or more, it will not go because of the saturation of the op-amp. So minus VCC being logic low. Logic low means 0. So that's why we are representing like this. And it Q is 1 if V out is greater than 2 VCC by 3. Sorry, VC, not V out, VC. If VC crosses 2 VCC by 3, then we have Q equal to 1, this one, by the logics. and then the transistor gets on. What will happen if the transistor gets on? Can anyone tell? This will be grounded. This point potential will be directly connected to the ground because this is just a switch operating in the cutoff region. So once the capacitor voltage crosses 2 VCC by 3, because it is a basic RC circuit, if you can see this part of the circuit, so voltage will rise like this, right? Try to rise like this. But as soon as voltage crosses 2 VCC by 3, what will happen? Because of the feedback logic, the transistor gets activated. So it gets on because the on command comes. This one, na? The on command comes at the base. And as soon as the transistor gets on, then this point and this point are shorted, right? Because it behaves like a switch. And as soon as this point gets grounded, so you have 0 volts here. So the capacitor will discharge through this path and the voltage will fall. Fall how much? For how much? Again, you see by checking, as soon as this voltage marked with red colors is VCC by 3. Why VCC? VCC by 3 because I am considering VCC as 12 volts. Now, as soon as it is less than VCC by 3, voltage is dropping because the switch is still on because it is grounded. So capacitor is discharging and its voltage is reducing. But as soon as it goes below VCC by 3 or tries to go below VCC by 3, again what will happen by this comparator circuit? This point is still at 2 VCC by 3, but the capacitor voltage is now going down VCC by 3. Then what will happen? Then this command will be low and this command will be high. Then this switch will be reset, Q equal to 0. Then this transistor will be open. Once this transistor is open, again the charging circuit is activated. So again it charges like this. So the variation of the VC is between only 2 VCC by 3 to VCC by 3. So it is between VCC by 3 to 2 VCC by 3. In this case, VCC is 12. So 2/3 of 12 to 1/3 of 12. So means that it is between 4 volts to 8 volts. So what is the answer? Answer is okay. So peak to peak value is 4 volts. Because it is 8 volts to 4 volts. 4 volts to 8 volts. So see this V peak to peak is how much? 4 volts only. Understood?
Yeah, yes, sir. Yes, sir.
So this is the problem of the week 1. Week 11, problem 1. So any other doubts?
Week 11, third question, sir. I got answer, but they not mention any millisecond or second. But analysis is somewhat different, sir. What I get 2.49. Can you explain that one, sir?
One second. Third problem.
Yeah, yes, sir. The same week 11.
Yes, so off time is being asked, right?
Yeah, yes, sir.
No, it is in seconds. It is asked in seconds.
Hmm.
So off time is directly calculated from the
Formula.
555 timer. Yes, 555 timer circuit arrangement, right? It has
Yeah.
directly the formula of off time, and you can just check from the T off. It is given as both are asked, right? On time and off time. So T off is R1 plus R2 into C into ln2, and T on is, I think, R2 into C. Yes. So ln means base E, right? And it will give you in seconds only. Now R1, R2 and C values you know. Right, this one. So you just plug in here 9K, and as C you take 0.4 millifarad. K and milli you consider will go away, cancel each other. Similarly, R2 you consider as 4K, and this has 0.4 millifarad. Then you check how much is coming. Just calculate both. Yeah, one is coming as the on time, and on the off time I am getting, this is 9, right? Yes, 2.49. Yes, answer is matching. Both
Yeah,
parts.
yes, sir. I got the same answer, but I wrote in milliseconds. That's why.
Oh, acha, that's why the answer is, because in seconds you need to be careful. In seconds they are
Yeah, yeah.
mentioning. That's why they have, so that the range is not there. Right? So
Yeah,
you have
yes,
to
sir.
always mention as per the asked units. In seconds they have asked. So because the formula gives you in seconds only. If millisecond is asked, then you have to multiply by 1000 and give the answer in millisecond based on the value of R and C. Accordingly, it will be specified. If nothing is specified, you answer in seconds only. If milliseconds you have to specify, it will be specifically written that you have to answer in milliseconds. So that is the thing. Okay. So that was the doubt problem. So any other doubts, or we can jump into the this week problems.
Yeah, okay, sir. Yes, sir.
So
No,
we
no,
have
no.
numericals on oscilloscopes, right?
Yeah,
Because we
yes, sir.
haven't discussed the numericals on oscilloscopes. So you have two problems on the screen. First, we'll start with the basic problem and just try it. Just take 1 minute and try. So these two problems to try. Maybe of question 1 I can write. So we want to see two cycles of the signal, of a sinusoidal signal of 50 hertz frequency, and then time scale frequency is being asked. And similarly, a 10 complete cycle signal of 50 hertz sinusoidal signal we want to see in the CRO. Then the time based signal frequency of in hertz is being asked. So both are in hertz. You have to answer. So kindly try this question. I hope you can see my screen and the problem is also visible. Let me know once done. Okay. It's done. Hello.
Yes, sir. What's up?
Yes. Have you done? Tried the problem?
I will calculate and then come back.
So time period is being given as, of the signal is being given as 50 hertz. Obviously, so 1 by 50 will be the time period in seconds for a 50 hertz signal. Now you want to see 2 complete cycles. So the time base signal frequency will be how much? So 2 complete cycles means?
So 25
2
hertz.
times of, yes, correct.
25 hertz, sir.
Yes. So it should be slower, right? To accommodate 2 such cycles. So 1 by 2 times this time period. So obviously it will be 25 hertz because 1 by t is that. So 25 hertz, right? Similarly, this one, 10 complete cycles are there. So you will do. It should be, the window should be further large and hence should be the time. And lower should be the frequency. The time is more, so lower is the frequency. So 1/10.
So 5 hertz.
Correct. Time scale 10 times. So frequency 1/10. So it should be 5 hertz. Right? Now go to the next problem based on Lissajous plots and unknown signal frequency estimation in the XY mode. So first problem, and this is the common statement for the 3 subparts. So first subpart is this question 2a. So we have first problem, the Lissajous plot is shown in the XY mode, right? XY plot. So from this you have to infer about the frequency of the y-axis. You can use Fy by Fx is number of intersections of horizontal axis, or I can write with horizontal axis divided by number of intersection with vertical axis. So maximum number of intersections, okay. This maximum is important. Yes, so we have you only have to calculate the number of intersections, right? Yes, so how many intersections with the vertical axis?
Only one.
So this is the vertical axis, right?
Yes. Two. Two.
And this is the horizontal axis. So 2 intersections, right? V1 and V2. So Fy by Fx is number of intersection with horizontal axis. Can you tell how many? Maximum number. So 1, 2.
3, sir.
And 3, 4. Because this one is periodic, right? So don't consider this. In one period, how many? So 4, right? Then you have been given the x-axis signal frequency. So you can multiply with fx and you get 120 Hertz. So now you can see this next problem. So these are the vertical and horizontal axis. So fy by fx is how many? Horizontal by vertical. Okay. So how many horizontal cuts and how many vertical cuts of this plot? Horizontally it is cutting only one time. So 1.
1, sir.
But
Vertical
vertical
2.
line, it is cutting 2 times. So V1, V2. But it is H1. So 2 vertical cuts. So now you have been given for the common data, fx already specified as 60 Hertz. So fy is 30 Hertz. Right? Which is desired unknown signal frequency. Now see this problem. Think and then answer, okay? Yes, what should be the answer? Any idea?
So first option is E, straight line.
Okay, it can be straight line, it can be circle or ellipse. 3 options are given. Now see, they have given you 2 data, that same frequency and same amplitude, but they are 90° apart. So one signal X in X channel, you may give R sine theta because R is the amplitude, frequency is omega t. And in the Y channel, another same amplitude signal R because it is given a same amplitude, but 90° apart. So sine maybe 90 minus theta or theta minus 90 I can write. Same omega t. Theta is omega t, right? So same frequency, same amplitude. Now what is x square plus y square? If you do it, r square sine square theta plus r square cos square theta, which is nothing but r square, and it is nothing but the equation of what? Locus xy traces a circle, right, with radius r. But if it would have been different, same frequency but different amplitude, then so in this case it should be a circle. But if so, we have another maybe question 3b. If same frequency but different amplitude, then what will be the option? Then locus would be of what? Like x square by a square plus y square by b square equal to 1, where a and b are the major and minor axis of the strength of the signals. So they would be of a ellipse. And question 3 subpart C, if frequency is same, amplitude is same, but no phase shift. So here also 90-degree shift is there, but strength was different. Now I am telling frequency same, amplitude same, but no phase shift, no 90-degree phase shift. Then it would have been a straight line. Because x is, for example, a sine theta, y is then same amplitude, same frequency, no phase shift. Then it must be sine theta only. Then x equal to y. So it is the equation of a straight line. And even if amplitude is different, okay, but no phase difference and same frequency, then also a straight line, but slope not equal to 1. That means here is the slope is 1. Sorry, here the slope is 1, y equal to mx, slope is 1 because the amplitudes are same. But if the amplitudes are different, slope is not 1. But still it is a straight line because the frequency is same and there is no phase difference between the two signals. Then it would have been a straight line. So these are the conditions for the various plots. Now come to the next problem, two subparts, or we can name them differently, question 4 and 5. So kindly try. Any doubt on the previous question?
No, sir, I clarified. No, sir.
So now try this problem. Done? I think this should not take that much time. Yes, hello.
200 megahertz for class 2 and DSO.
Okay. How much?
200 megahertz.
Yes. Correct. So you are using Nyquist, right?
Yeah, it's a Nyquist.
So Nyquist theorem says that you have to at least sample at 2 times the actual signal frequency for proper acquisition. So here it is given already that the sample or F sample is 10 to the power 6 into 100 hertz, which is nothing but 100 megahertz. It is the acquisition frequency. Now what should be the F signal max? Because this should be the minimum frequency. Minimum you should sample at 2 times. So maximum possible signal is 2 times of this. This could have been even lower. Lower it is better, but you cannot cross above 200 megahertz. Then that 2 times criteria will be violated. So F signal min should be there, not max. Minimum. Oh, sorry, maximum. Maximum was correct, right? You cannot cross beyond 200, right? Maximum allowed is 200. It can be lower also. So a slow varying low frequency signal can be acquired faster. That is sampled much higher at much higher frequency, no problem. But the sampling frequency should be at least 2 times. So the maximum allowed signal frequency to be measured is 2 times of the sampling frequency. So that's why 200 megahertz. Now try the next one using the same concept. Now the signal frequency is known to you. 15 megahertz. You have to capture this signal. So what should be the minimum sampling for this signal? It should be 2 times, right? At least 2 times. So F sam at least 2 times. So F sam min is 2 times of 15 megahertz, which is nothing but 30 megahertz. Done? Any doubt? Please let me know if there is any doubt. Or I can repeat once again. Any doubt? So here it was minimum sampling frequency, and here it was the maximum allowed signal frequency. The information comes from either the sampling rate and or the actual signal to be estimated, and from there you can estimate the minimum sampling frequency. Any doubts? Kindly let me know. I think you can hear me. Shall I proceed?
Yes, sir. Yes, sir.
Okay. So try this problem. I think the problem is now visible on your screen.
Sir, option A is correct answer, sir. No phase shift.
Yes. Because it is given no phase shift, right?
Yeah.
Same phase angle. Amplitude can be same or not same, but these two are very important. Same frequency, same phase angle. Implies it should be always a straight line. No phase shift, right? That's why. So try this problem. I think this one is clear, right? So option A is the correct option. Hope there is no doubt. So try the next problem. So you have been given a Lysage's plot like this in the XY mode, and then one of the signal frequencies is given. The horizontal signal frequency is given, horizontal axis, and both are sinusoid. This is also specified. Now the XY mode plot is given, and you have to estimate the frequency of the Y-axis signal. So analyze and then solve this problem. Yes, done. So Fy by Fx is maximum number of horizontal intersections divided by maximum number of vertical intersections. So how many horizontal intersections are there? 1, 2, 3, 4, 5, 6, 7, and 8. So 8 horizontal intersections. And vertical is 1, 2, and 3, 4. So 4 vertical. So it is 8 by 4, right? Which is nothing but 4 by. So 2 times, right? No, yes, 4. So 2, right? Is it correct or something is missing?
Sir, in vertical line, it should be 6, no? Or 2
Correct,
times
correct,
it is
correct,
something like
correct.
this.
Vertical line should be 2 to 4, 6.
Okay.
So 6 vertical, yes. So it is 4 by 3, right? So 4 by 3. Then you have this known signal frequency is 250 hertz. So this is 250 times 4 by 3. So which is coming around 1000 by 3, right? So 333 hertz. So 6 vertical intersections. Maximum number of vertical intersections, right? So no doubt, I think, in this problem. So solve this one. Yes, solve this problem. Okay.
The answer is 133.33.
1.
33.3 something.
Yes, correct, correct. So Fy by Fx, if you see the vertical and horizontal, so horizontal is 2 and vertical is
Vertical 6, horizontal is 2.
yes. So max so 6. So 2 by 6 is 1/3. So this is 400. So you get 400 times 1/3, which is nothing but 133.33 hertz. Okay. Now solve the next problem. I think the problem is visible on your screen.
So 600 hertz, sir.
Okay. So Fy by Fx, if you see, we have 2 here and 3. So vertical is 3. But the horizontal is 1, 2, 3, and 4. 4 by 3, right? So Fy is coming 4/3 of 450. So we have 150. So 600 hertz, right? Right? So I think you are now fluent with the Lysage's plots and determining the frequency of the unknown signal. Also commenting about the various patterns of the Lysage's plots from the various information of amplitude and phase angle difference and frequency. So those things you are now fluent with. Now let us go into the numericals on the transistor based measuring instruments, which is covered in the final week. Okay. So before just starting this, just keep some formulas and some important points in mind. So maybe some recap. So you have this activation potential of a transistor always, and then you have some resistance here. This is RC, this is, I can say, RE, and also maybe in the base some RB. So what type of transistor this is? This is a NPN, right? NPN transistor, where this is the collector, this is the base. Obviously you have some driving voltage, which is known as VB with respect to ground, and this is the emitter. So this node is not the collector. This node is the collector, right? The transistor node. So this node is the collector. Similarly, this node is the base, and this node is the emitter. So VC is nothing but VCC minus IC into RC, if this is IC. Similarly, if this is IB, and if this is IE, then you see VC, I am terming this node potential with respect to ground. So this is VC with respect to ground, which is nothing but VCC minus IC into RC. Simple. Now you have another thing, that is I using KCL, that is IB plus IC is nothing but IE. And you know IC max is nothing but beta IB. Then what is IE? IB plus IC, but you have IE max as IB plus IC max. So IB plus, just let me charge the battery. So what will be IE max in terms of IB? 1 plus beta, right? So these are all the governing equations that you will need. Now generally we keep this voltage constant, VB, and your VB minus IB RB is nothing but VBE, I can write, because base with emitter is grounded, so VBE. But emitter is not grounded, emitter is here. This is the emitter node. So we cannot write this VBE, we can write this as something else. So VB minus IBRB is this node potential. So this we can call as VB. So I can write this as V input to avoid confusion. This voltage, driving voltage, I can write as V in. So V in minus IBRB I can write as, it is the input voltage minus the base current times RB. I can write this as this node potential, and this node is nothing but the base of the transistor. So this is VB. But it is still not with respect to the emitter, it is with respect to the ground. So now you see this VBE is 0.7 volts, because if IB exists, then your base to emitter voltage is almost 0.7 volts because of the characteristics, base emitter voltage and the base current. So approximately this is like this. So IB can flow only if VB is 0.7, and then it's any amount of IB can flow decided by the input voltage and the resistances, but it is not affecting very much the VBE. So VB is 0.7 volts, then you can calculate VE with respect to the ground as VB, this one, just apply KVL, VB minus VBE. Right? Will give you VE. And VE by RE will give you IE. Now, since V in is constant, and for a fixed value of resistance, see, this VB is constant. So VB is constant because this is constant. This is constant for a constant resistance. So this is constant. VB is constant. Constant minus constant. VE is constant. And it almost follows the emitter if these resistances are not there. So if this RB is shorted, then V in input voltage and emitter voltage almost follows each other, because if RB is 0, it becomes emitter follower. Why emitter follower? Because input voltage, since V in minus VBE is VE. So VB is almost constant and V in is almost constant. So VE follows V in, emitter follower circuit. You must have also seen in the lectures also. So this is how it works. It works like this. That the relations will hold if this drop exists. That means this VC should be greater than 0, or VCE should be greater than 0, and obviously VCB should be greater than 0. Some drop should be existing for active mode operation. And then using KVL, you can just draw the load line or the, you can say, operating characteristics, and the intersection point will give you the value of IB, and beta should be given in the problem. So these are all the fundamentals how we tackle these transistor based circuits. So with this knowledge, you calculate, because VBE is given and beta is given in this problem, and VCC is also known, and you see no resistance is here, so it becomes a emitter follower circuit. Emitter follower circuit, BJT based, right? And you have a measuring instrument. So this meter resistance is 1 kilo, so it is measuring the voltage, but it is not loading the circuit because this current is low, IB is low, and it is producing high IE, so more deflection for small current. So that means input impedance is more of this kind of circuits, and it is desired for better voltage estimation without loading effect, because input impedance should be ideally more of any voltage measurement device connected to the circuit across the nodes across which you want to measure the voltage. So these kind of circuits are suitable because they have high input impedance and produce more deflecting torque for a small amount of current, taking a small amount of current. So they reduce the loading effect also. So now knowing all this, you calculate these 5 parts. So for this 8th question. So try this problem. Okay. Any doubt you can ask me. You have these parts A, B, C, and D. 4 subparts, right? You're trying, right? Am I audible? Hello?
Yes, sir. Audible, sir. Yes, sir.
So try and take some time and try. Okay, the 4 subparts are given. So you need full scale deflection, right? For E means the input voltage, right? So part A. How to do this? Any idea? So we need the value of RS. And I know that the full scale deflection current is 2 milliamps, which should be IE max. So we need to calculate RS such that if we apply 5 volts here, we'll get the 2 milliampere as IE. So VE is nothing but 5 volts. Or I can tell this not VE, sorry for the nomenclature, this is not VE. So E is 5 volts. So E is 5 volts, right? And what is this? This node potential I can term as V. So don't confuse the V, E and E. E and VE are different, okay? So E is 5 volts. So E minus 0.7 volts is 4.3 volts. Because with respect to the ground, this voltage is 5 volts. Now here you get a drop of 0.7 volts. So what is this node potential with respect to the ground? It is 4.3 volts. So that is nothing but VE, right? Agreed? So once you get VE, you want for this particular E, you want IE to be 2 milliampere. So accordingly, the resistance should be calculated, right? Because you have 1 kilo ohm here from the meter and some additional resistance appearing here. Together should draw 2 milliampere current. So IE is 2 milliamps equal to VE, which is 4.3 volts divided by net resistance, which is RS plus R meter. Now R meter is given. RS needs to be calculated from the condition of full scale deflection. So now can you tell me what is the value of this RS? So RS plus RM is nothing but 4.3 divided by 2, and you get a milli, so you take it above and get a kilo. So it is 2.15. Okay. But your RS is needed. So this is 2.15 minus 1K because the meter resistance is 1K. So you have 1.15K. First part done, right? Any doubt? Just applying KVL and the full scale deflection condition for the applied input voltage of 5 volts because that is needed. Accordingly, you need to calculate RS value in ohms. But in ohms, be careful. So part A answer RS is 1150 ohms. Be careful. Don't answer in kilo ohms unless and until it is specified. If nothing specified, give the answer in ohms. If kilo ohms specified, you need to obviously answer in kilo ohms. But here already ohms is specified, right? Even if not specified, we need to give the answer in ohms if nothing is specifically mentioned. Just like you have to answer in seconds. Similarly, if nothing is specified, you need to mention the answer in ohms. So I see some new persons joining. So I will give some time for them. We are solving this problem, the emitter follower problem, BJT based measuring instruments, and we have done the first part, part A. So just for recap, the part A is asking what should be the value of input voltage And for given input voltage as 5 volts, they are asking to calculate RS such that this meter shows full scale deflection. So you know that this voltage, just re-explaining what we just calculated. So input voltage E is 5 volts, and this is, since base resistance is 0, this is an emitter follower circuit. So this node potential is 5 volts with respect to ground, and this is a NPN, so a drop of 0.7 volts is there. So we get this node potential, the emitter potential with respect to ground, as 4.3 volts. And if this is 4.3 volts, then this divided by net resistance will give you the emitter current, IE. And I at full scale deflection should be 2 milliampere through the meter. So we put that condition of full scale deflection, that is 4.3 volt at emitter divided by net resistance RS plus RN should be 2 milliampere, because it should be full scale deflection for input voltage to be 5 volts. And accordingly, RS is calculated as, the meter resistance is known, it is given as 1K. So 2.15 minus 1K we get as 1150 ohms as the RS, this resistance value. So part A is done. Now calculate part B, C and D. So B asks you to calculate the percentage deflection if the, so full scale deflection occurs as 2 milliampere. Now percentage deflection for 2.5 volts applied here. So now I apply 2.5 volts. Second case. Now calculate how much percentage deflection. In this case, obviously for the same value of RS. RS we have already calculated, because for 5 volts applied in the input, we want full scale deflection for 2 milliampere. The emitter current should be 2 milliampere, full scale deflection current. But now keeping that RS as 1.15 kilo ohms, we want to see how much is the percentage deflection if the input voltage is reduced to 2.5 volts. That is the question. And in the next part, you want to calculate the input resistance when E is 5 volts, because you know when the voltage level changes, these kind of non-linear instruments, their input impedance also will change non-linearly. So this is not a linear device. The behavior will change non-linearly. That's why, to make you see that, we have given different voltage levels, input voltage levels of this emitter follower configuration, and asked you to calculate the input impedance with varying input voltage. You will see that as input impedance varies, now as input voltage varies, the input impedance also changes. That is the main point you will see after you calculate. So that is the point to observe. So also the base current will change, so non-linearly with the voltage. So you calculate the input impedances or input resistances with different values of voltage inputs. And obviously for different voltage input, how much is the percentage deflection in the meter. So these three simple subparts are there. I'll just bring this diagram in a new fresh page. And so part A is done, right? So part A already done. Sorry, part A is done, right? So this is already done. Now you solve these three. This is already done. So these three are pending. So this is emitter follower, as we discussed, because this resistance is 0. So whatever is the input voltage minus 0.7 is the emitter voltage. So emitter and input follow each other. That's why emitter follow. So now calculate these three subparts. I hope it should not take more time. Just you need to just analyze and solve accordingly. I'll give you some time. Kindly think and solve. So simply we are being asked to calculate percentage deflection, percentage of full scale deflection. So full scale deflection current is 2 milliampere, already known. Now if we can find this current, the emitter current that is flowing through the meter, for the input voltage to be 2.5 volts instead of 5 volts in this case, then only we can calculate IE new by IE old. IE old was the full scale deflection current, as a percentage new current as a percentage of old full scale deflection current is nothing but the percentage deflection. So use this. So what you need to do in this, you need to calculate only the new emitter current for this applied new voltage. So V in new is 2.5 volts. You need to calculate IE new to calculate the percentage deflection. So this is part B. So calculate. Any doubts, you can let me know. Just unmute and let me know if you face any doubts or you need any re-explanation. Done? It is easy, right? So V in new is what? 2.5 volts. So now V emitter, V in is calculated. So this V emitter is needed to calculate IE new. So V emitter new is this node potential. So it is this input voltage minus 0.7 volts VBE. This drop is there, right? Of 0.7 in the active region, right? So input voltage 2.5 minus 0.7 volts is the emitter voltage, new emitter voltage. So how much is it? It is 1.8 volts. So now you calculate IE new is nothing but 1.8 volts divided by this RS. RS is 1150, right? And this is RM. 1150 plus 1000. Calculate how much is the current in milliamps. New emitter current. Tell me. Yes.
So 0.0083 milliamps.
Is it? Check it. Is it 0.00 or
0.83.
right? But you know that the full scale deflection current is 2 milliamps. But now the current flowing through the meter for a new input voltage of 2.5 is this. So I told you percentage deflection is nothing but new current flowing through the meter, and milli will get cancelled. Old it was 2, As a percentage of that, we need to calculate how much should be the deflection for this new flowing current. So how much is the deflection? (41.86%), right? Now solve the next two parts, the resistances. So for resistance, what you need to do? Input resistance. It is V input by I input. I input or I base. So base current needs to be calculated for both cases. So for both cases, we know one thing, that the emitter currents we know. So let me do it in a fresh page. So for the input resistances, both emitter currents, IE, when VE is 5 volts, sorry, not VE, when V in is 5 volts, I can tell. So V in or E. E is this voltage, I call it V in for simplicity. So we have till now done two parts, when this is 5 volts or this is 2.5 volt. What is IE coming? For 5 volts, I is 2 milliamps. For 2.5 volts, I is 0.837 milliamps. And accordingly, RS is calculated as 1150 ohms. And meter resistance is already given as 1000 ohms. But you need to calculate I in for both cases. Then only you can do V in by I in to calculate the what? R in. Because R in is asked, right, for this voltmeter. Overall net voltmeter arrangement. What is the, if you see from here, what is the input impedance? So V in by I in. This information already we have. So how to calculate I in? I in means IB. So we know beta, right? Can you help me with how to calculate I in? This is IB, right? IB or I in. So what I can write? IE and IB relation. Yes, someone? Because IC plus IB is nothing but IE. Now IC, this is beta IB. IC is beta IB plus IB equal to IE. So IE is nothing but 1 plus beta IB. You apply this relation. So IE we know, IB is nothing but IE by 1 plus beta. In this case, it is nothing but 1 by 100. So IE by 100, sorry. because beta is 99. So for both cases, you do 1 by 100. And you calculate R in. So R in will come V in by IB. So 2 milliamps by 100 and 0.837 milliamp by 100. So what will it come? V in is now how much? For this case, 5 volts. And I in is nothing but IB. And IB we have calculated as 2 by 100 milliamps. So milli goes above and gets kilo. It is 500 by 2 kilo ohms, which is nothing but 250 kilo ohms for the first one. And for the next one, R in is nothing but 2.5 divided by 0.837 by 100 milli, but it goes and gets kilo. So it is 250 by 0.837 kilo ohms. So it is nothing but 298.68 kilo ohm for both the two different applied input voltages. Calculate and check whether it is correct or not. So for the first case, when input voltage is 5 volts, we have the input resistance as 250 kilo ohm. And for the second case, when input voltage is 2.5 volts, we have the input resistance offered by this BJT emitter follower based measuring instrument voltmeter as 298.68 kilo ohm. Any doubt? Yes, any doubt?
No, sir. No, sir.
So now we move to the next problem, right? Okay. Question 9. So this is a linear ohmmeter circuit, and the resistance to be measured is this. And you have been given the information that this reads 3 volt. So now from this information, can you calculate Rx? That is being asked. So for that, what we need to do? If we know this voltage across this element, so 3 equal to IR, some I emitter times R. If we know this current, voltage across the resistance already known, then only we can determine the Rx. So we need to determine current through the resistor. IE is current through Rx. Then only we can calculate Rx, right? Because voltage across resistor is known. And is 3 volts. So now current needs to be determined, this current, IE. So whatever voltage appears here comes here. And this voltage first we need to determine. And here we are giving 12 volts plus 12. So here no current can flow. So what is this voltage? This is grounded, right? So V, I can say positive is just by voltage division we can calculate 12 into 930 because we are calculating this voltage with respect to ground divided by 570 plus 930. How much is it coming? Calculate this node potential with respect to ground. Yes, how much is it coming? Okay, let me check. 7.44 volts. So this voltage is 7.4.
7.4.
Yes, so due to virtual short, we can also assume Bn as 7.4 and hence this as 7.44. Now, once we calculated this voltage, what can we say? Yes. Can you find out IE? Yes, can you find out IE? So this is not IE, right? This is IE. And the drop happens like this. So I think you can identify what I am telling, right? This is emitter. This is, I can say, base. And this is collector. So this transistor is inverted, right? Yes. And can you tell me what kind of transistor this is? This is P, this is N, this is P. PNP. Yes. So this drop is 0.77. So what is this thing? Sorry, I wrote one thing incorrectly. This current will be this current will be collector current. So this is not IE, this is IC. Because this is collector is the emitter. So once we calculate emitter current, then only we can calculate the collector current. So calculate once. What is this? Is 7.44 volts. So 7.44 volts. What is IE? 7.44 plus 0.7. You see KVL. This node potential with respect to ground is 7.44 volts. This node potential I am talking. Then you have a plus 0.7 gain. So now we get VE with respect to ground. And what is VC? C, 12 volts. So what is the difference across this resistor? So IE is VCC minus VE divided by 10 kilo ohm. I hope you can see this as IE. So now calculate what is IE. Obviously in milliamps. So 12 minus 7.44 plus 0.7. That is minus 0.7. Should be plugged in as here. How much is it coming?
So 0.386 million.
0.
386.
Let me check. So 3.86 milliampere, right? Sorry, 0.386, correct. So IE is this one. Now beta is high, right? So IB is generally very low. That means your IE and IC follows each other. Why I can write that? Because you already know IC is beta IB. And IB is very small, right? Because generally you see that this current is very small for that very high current flow. So for a high gain, it is IC by IB, beta is very high. So IB is generally low, right? So that's why we can neglect it. And because the input impedance we saw, that's it very high. So IB is low and IE follows IC. So almost they are same. So IE I calculated, IC I can write as same, 0.386. Or else you can also just check, cross check that what should be the value of this emitter current. Emitter current we calculated, right? 0.386. And then how can you calculate that current? So that current you can calculate from these characteristics VBE. From the VBE characteristics, but the current is given as voltage is given as 0.7 volts drop. And from the transfer characteristics, you can get the quiescent point, that is IB, but we don't have that. That is not given already. But generally for a high gain, because this current is itself very small, this IE, and so that's why IB should be still lower. So you can neglect IB. But exact calculation of IB will come from the characteristics and the intersection with that. Yes. So, but you can assume that to be very low. So IE follows IC. I hope this assumption is very clear. Now, if it is true, then we know IC. IC is known because IE almost equal to IC. And now from here you can calculate Rx. Rx is 3 by IC, 0.386 kilo. So how much is it coming, Rx? 3 by 0.386. It is 7.77 kilo ohms. Got it? So you can make this assumption if IB is not known, because you don't have any resistance and known voltage here. If you have known voltage V in minus IB into RB, if some base resistance is there, then you can calculate the base voltage VB, and maybe you can calculate that drop, and VB can be known, and V in known, RB known, then IB can be known by assuming that VBE is 0.7. So in that way you can determine IB, but here no resistance is there, so you cannot determine IB. So in general cases IB is very low because IE and IC are already low and the gain is high. So the resistance of this kind of circuits, the input resistance is very high. So in all practical cases you can assume the IB to be 0 or neglect that. So almost IC and IE follows each other in these emitter follower configurations. Okay. So I hope this point is clear, or do you need some explanation? Because in kilo ohm it is asked, so 7.77, because this is 12 volts, right? Clear? Yes, clear? Hello? Okay.
Yes, sir. Yes, sir.
So now you move on to the next problem. Yes. So try this problem. So beta is given and VBE drop is now changed, 0.65 volts. And the meter resistance is already given as 300 ohms, this 300 ohms. And you have a simple configuration. So we have been asked to calculate the required value to obtain full scale deflection for just like the problem we solved. So 10 volts is applied and you need to estimate RS for which full scale deflection occurs. And the full scale deflection reading is given as 4 milliampere. So already one type of problem like this we solved. So just first part we can solve and next part you can give me the answer by solving it yourself. So what will be the first part? I will help you. Next two parts you solve yourself and tell me the answer. So 4 milliampere is the full scale deflection current. That means it is emitter. So always check this sign. This means this is the emitter, right? Base, this is emitter, this is collector. And what kind? It is NPN because arrow is from here to here. So that's why. So now you see this is the emitter current given 4 milliampere. But we need what? This 4 milliampere is given as the full scale deflection current, but we need this voltage, then only we can calculate RS. So VE with respect to ground is needed, but we know V in is 10 volts. This is a emitter follower configuration because RB is 0. So V in is 10 volts. So what is VE? VE is nothing but V in minus 0.7. just the drop. So VE minus 0.7 is VB minus 0.7 is VB, right? As RB is 0. So VB, V in all same. Minus 0.7 will give you, that is VB minus VBE will give you VE. That is what I am writing. But this is not 0.7. This is 0.65. So 0.7 will not work. Do 0.65. So what is V in? 10. So what is VE? 10 minus 0.65. Which is 9.35 volts. Correct? Now we know VE. Once we know VE, we can calculate 9.35, that is VE, divided by net resistance, that is RS, plus the internal meter resistance. And this will give us the full scale current according to the condition as 4 milliampere. This is full scale deflection. So now we need to calculate this unknown parameter. So calculate what is RS coming. So this is part A. Calculate RS in kilo ohm or in ohm, it is asked. You plug in the values and calculate the RS. So 9.35 divided by 9.35 divided by 4, yes, and 1000 needs to be multiplied with that, and minus 300. So I am getting 2037.5. Are you getting the same? Because we need to answer in ohms.
Yes.
Part A I am getting, okay. Now part B is what? For same RS, you tell me what will be the percentage deflection. That means you have to calculate this current again for a new input voltage, V in equal to 5 volts. So this is part B. So just calculate 5 minus 0.65 is the new VE if V in is 5 volts. So this is part B. Now for V in is equal to 5 volts, you have VE new as this. Now similarly IE new will be changed 5 minus 0.65 divided by voltage by current. Voltage by resistance will be current. So resistance is 2037.5 plus 300, the meter resistance. Net resistance, net voltage, emitter divided by net resistance, which is 2337.5. This is nothing but RS plus RM. Will give you new emitter current. Calculate how much is it coming. 5 minus 0.65 divided by 2337.5 into 1000. You give me the answer in milli. 1.861 milliamp. This is new I. Okay. But we know the full scale deflection current is 4. So 1.861 by 4 into 100% is the percentage deflection when V in is 5 volts. So calculate how much it is coming. 46.52%. Coming? Everyone getting?
Yes, sir. Got same.
Yes. So now you calculate part C, the input resistance. You know already emitter current. For V in equal to 10 volts, you know the emitter current. So for V in equal to 10 volt, we know IE as 4 milliampere. For the given resistance values as 2037.5, and meter resistance is 300 ohms. We know all these information, and beta as 199. Now can you tell me what is IB? Is nothing but I in, right? Because IB plus IC is IE, but IC is beta IB. So beta 1 plus beta times IB will give me IE. But I need IB. I know IE. So IB is IE by 1 plus beta, which is very small. But I need this to calculate the input resistance. So what is it? IE or I in, IB or I in, I need to calculate as IE by 1 by beta. IE I know 4 divided by 1 plus beta. 1 plus beta is 200 as milli. So this is I in 4 by 200. So what is following from here? What is R in? It is V in by I in. So V in is 10. I in is 4 by 200. But a milli is there. So a kilo will come. And hence you get how much?
500 kilo.
500 kilo. So answer is 500 kilo. Yes. So I hope with this you got a flavor of solving the various BJT based circuits for measuring instruments. And similar circuits you can solve to get your concepts clear. So we have solved a variety of problems today. And tomorrow, a similar time, 7 to 9, we have a overall session to cover various more additional problems to give you a preview of all the various concepts and that we have solved in the past 12 weeks. And that will be helpful. So I request you to kindly join tomorrow's session. Same time, 7 to 9 p.m. So that will be the final review session. Okay. Where we will discuss all 12-week concept-based problems. And that will help you to recap all the weeks. Okay. So I wish you best of luck for your exams, which are to be held in the month end, I guess. 27th, right? And I request you to attend this session, final review session in the 13th week. So I will cover it tomorrow, which is Wednesday. And the date will be obviously 16/10/2024. The timing is this. Same link. You must have got the notification also of the extra session. So this session I am taking specifically for you. So I request you to join this session because many of you are not attending, but I see that all of you are watching the playlists and the views are increasing, but the live session attendance is very low. So I request you to kindly join and get your doubts clarified in the live session itself, which is basically helpful because these sessions are meant to be interactive. So if I don't get to interact, there is no meaning of taking the live sessions, additional sessions, right? So these are designed specifically to get the concepts, to review the concepts again and get them clarified of all the 12 weeks. So I have specifically taken this extra session for you to get your whatever concepts you feel might not have been covered yet, or you need a recapitulation or the problem solving of such concepts. We can discuss those kind of problems specifically as per your needs, and hence we'll discuss and interact more and get the doubts clarified. So I hope you will join tomorrow's session and we'll have a good discussion and doubt solving session, right? So with this, I end today's session. If you guys have no more doubts, and I obviously wish you all the best for the final exams. So these slides and all will be available in the course portal, and you can click and visit the playlists and the materials that I am teaching. So obviously you can just go to the course portal, right? So I just write. So you can just go to the course. One second, I am not having the charge. So are you guys able to see the slides that I am uploading? You know where from to access those? Or you don't know? Then I will tell you.
Yeah,
Are
we
you
will
good?
access the live storage, sir.
Yes, you can access the drive link, right?
Yeah, yes, sir. We are
To the
access.
spreadsheet. So you go to the course portal, and there is a section named live session, and there you get directed to a spreadsheet from where you get all the playlist link as well as the material links, material drive link. So from the material drive link, you will get the slides. And if you want the live sessions, if you want to see the recorded sessions that I am doing, you can go to the playlist link. Obviously, you can just subscribe so that you can see the notification also. Or else you can just click the playlist link, and from there you get redirected to the weekly sessions that I am recording and also uploading in YouTube. So I hope there should not be any problem in recapitulation, and I urge you to join the final, request you to join the final tomorrow's session, right? That will be a good review and interactive session to get your doubts clarified. One-to-one discussion we can do and also solve more problems and get those doubts clarified finally to prepare you for the exams. Good recap session we have designed. So hope you will join, and if no more doubts, then we can just end this session. Yes.
Thank you, sir. Thank you so much.
Yes. Thank you.